Hello, my name is Sophie. I'm a third year chemistry student and a Trioso Camry ambassador. The Our World module aims to get you ready for studying the ever-changing Earth topic at GCSE. In the next few videos, I'm going to be talking to you about the present atmosphere and the processes affecting it, changes in carbon dioxide levels, as well as global warming and addressing the problems of it.
In this video, we will be focusing on the composition of the Earth's present atmosphere. To start with, we are going to look at the proportion of gases in our atmosphere. For the last 200 million years, the gas compositions have been consistently around those of today. The air that we all breathe is made up of 78% nitrogen, 21% oxygen, and 0.04 carbon dioxide. The remaining 0.9% is made of argon and small amounts of water vapour and neon. The composition of gases are maintained by three processes: combustion, respiration, and photosynthesis. Let's go through each one of these in more detail. Combustion is the burning of fuels in oxygen. The general equation for combustion has fuel and oxygen as reactants and produces carbon dioxide and water. We burn fossil fuels to power our homes and industry, as well as powering vehicles. The amount of fossil fuels burnt has increased drastically from the consumption of 10,955 terawatt-hours of fossil fuels in 1920. In 2019, we burnt approximately 136,761 terawatt-hours of fossil fuels. This is an increase of 1,148% in 100 years. To put this in perspective, 1 terawatt is a unit of electricity and powers roughly 1 billion light bulbs. Respiration is the process of breathing in humans and animals, using energy and oxygen. The energy comes from a sugar called glucose, which is found in our bodies. The equation for respiration is the reaction of glucose and oxygen to form carbon dioxide and water. On average, a single human breathing releases 1 kilogram of CO2 a day. This would be like breathing out a whole bag of sugar. Photosynthesis is how plants produce their own food. They use energy from sunlight to produce glucose. The equation for photosynthesis is carbon dioxide plus water goes to glucose and oxygen, with UV rays from the light helping the reaction to occur. Photosynthesis occurs in all plants and even some algae. The average human breathes in 740 kilograms of oxygen a year. This is about 7 or 8 trees worth of yearly oxygen output. Thankfully, our present atmosphere is a lot different from the Earth's early atmosphere, as humans as we are today would not have evolved. Let us take a look at how it was over 4.6 billion years ago. Scientists have suggested it to have been a lot like Mars or Venus, which is mainly carbon dioxide. This was partially due to the number of volcanoes releasing CO2 along with small amounts of methane and ammonia. However, the Earth began to cool, radiating its heat into outer space, allowing the water vapour in the atmosphere to condense and form the oceans. This reduced carbon dioxide levels as the CO2 dissolved into the oceans, creating carbonates, which precipitated to form sediments, forming a carbon sink, meaning it holds the carbon dioxide. Other carbon sinks are fossil fuels such as oil and gas, which are drilled from deep within the oceans. As the level of CO2 slowly reduced, algae and plants were able to form. Plants began to photosynthesize, increasing the oxygen levels and further reducing the CO2 levels. Once the oxygen levels were high enough, animals evolved, due to having enough O2 to respire. In the next video, we will look at the modern changes that are affecting the carbon dioxide levels in the atmosphere in more detail. Thanks for listening.